Oh, okay, sorry for that. Hello, hello. Okay, for the first question here, from the FFX, the question is asked for composition of three functions. So it's like a FFX is equal to G O H O what is O G. So you have to determine what is GX, HX, and GX. It's a three function, right? So for doing this part, I like to see it from the whole part, right? So it's 1 over some function. We call it HX. We can write it like this. And in the HH, we can say that the HH is the square root of some function 2, which is GX. So the GH here is the function of 1 over x. The SH is square root of x, and the GX is x plus square root of x. So if you put the GX into the HH and put the HH into the GX, you can get the FX here, or 1 over x plus square root of x. Is it okay? Is it clear? You have any question? No? For the online student, if you have any question, you can say something or just chat in the Google Meet. It's done. No question. We can move to second question. Second problem here. Okay. This is some things that Professor Imans already discussed in the class. So he's given a graph, and we asked about the limit for this graph. I'll give you 5 minutes to answer this, and we can discuss it later. Okay, finish, or you cannot, or you cannot do this. Okay, anyone want to try the first one? As a limits approaching 2 plus. No one can do. Hello, hello. Okay, as limits approaching 2 plus here, you can see from the graph, you go to x equal 2 here. For the limit approaching 2 plus means that the limit approaching from the right side of the function. So from the right side, the answer is around here, so it's 3. So the answer of A1 is 3. You just see it from the graph here. Okay. And number 2, limit approaching 3 minus 3 plus. So what's the answer? No one. Limit approaching minus 3 here from the right side. So it's 0. What if I ask the f of 3? Oh, sorry. F of 3. Yeah. F of minus 3. So it's equal to what? Is it 0 or is it minus 2? Minus 2, right? Thank you for your participation. It's very quiet here. So number 3, limit approaching minus 3. What's the answer? Sorry? Huh? Oh, yeah, that's true. Do not exist. Sorry, I cannot hear you first time. You are wearing the mask. So, can you hear my voice clearly from the backside? Okay. And for number 4, uh, limit approaching 4. 4, 2, 3, 4. What's the answer? 2, right? Limit. So, next one, 5. Limit approaching 0. The answer is infinity, because it's approaching a higher, and higher. Okay. And limit approaching 2 minus, minus 2. What is it? 2 minus, yeah, 2 minus. 2 minus from the left right now. And that's minus infinity. So what if I ask about the limit of x approaching 2? What's the answer? Limit approaching 2 here. We know that the limit from the left side and the right side is not same, right? So the limit approaching 2 itself is do not exist or undefined. For the next question, the vertical asymptotes for this graph. What's the equation? If you write this down, I'll move to the next page for the answer. So from this graph, you know that the limit, the answer that close to infinity is at 0 and at 2, right? So for B, the equation for vertical asymptote is x equals 0 and x equal 2 from here and here. And C, at what number f is discontinuous? Discontinuous, for we can see it from the graph. Actually, it's right here. Sorry. Wait. Why is it not moving? Okay. It's right here, -3, 0, 2, and 2, 3, 4. So for C is x equal -3, 0, 2, and 4. Right, -3, 0, 2, and 4. So next one is maybe a little more difficult than the previous question. I'll give you 15 minutes to complete all of this question. Oh, and for the hint, this rotation here is to round down to closest in picture. That means if you have the number 2.99999, etc., it will be rounded to 2. And you have the 4.2, it will be rounded into 4.2. So it's like a round down to closest integer. Okay, let's discuss it. Okay, for the first one. Okay. 7. X approaching 0 for 1 minus square root of 1 minus x squared divided by x. So first, we want to try to substitute the limit first. So if we input the 0 here, that will be 1 minus square root of 1 over 0. That will be 0 over 0. And that's cannot be right. And one way that we can use to solve this problem is to use the conjugate. So we multiply it by, let's write it again. Over x multiplied by 1 plus square root of 1 x squared per 1 plus 1 minus x squared. So we can get 1 minus square root of 1 minus x squared over x as limit x equal to 0. 0 square root of the square of square root is just the numbers inside. So 1 minus x squared over x. So that's become, let's write it here. X approaching 0 is x squared minus x squared over x. You can cancel the x from the below, and you can substitute the 0 right now. So the limit x approaching 0 is just 0. Okay, we get the satisfying answer here, 0. And for the second problem, as limit v approaching 4 plus v minus 4 for absolute v minus 4. So for the absolute sign here, we have two conditions. The one that the v is less than 4 and the one that v is more than 4. If the v is less than 4, the functions became, if less than 4, then it's become minus, right? So we have to add the sign, minus sign here, and v minus 4. If it's more than 4, we can just write the function again, and it's v minus 4. The limit is asking about the plus 1, so it's greater than 4, right? So we can just rewrite the question like this. V is approaching 4 plus for v minus 4 greater than 4. Oh, wait. Is it correct? It's 4 minus. Oh, sorry. Wrong question. 4 minus v. 4 minus v for output. So if the v is lower than 4, we have the normal one. And if v is more than 4, so it's 4 minus something's more than 4, that's become negative. We have to add the minus sign here. Something's wrong here. Okay. Minus, yeah. So if it's approaching 4 plus, it's greater than 4, so it's minus v minus 4. And we can cancel this one, and for the v approaching 4 plus, it's -1. So what if I ask about the limit approaching 4? What's the answer? What? We can check this, we can answer this by checking for the limit approaching 4 minus. So we get what? Sorry, 3 minus 4 over, it's lower than 4, right? So we use this one. And same, cancel out, and we got 1. So the limit is v approaching 4 is do not exist. Right? The third one, limit x approaching 0. Oops. Sorry about that. So same as before, we have two conditions here. When it's the x is between 0 and 1 and -1, and 0, right? So we can check this one by checking the left hand side and right hand side limit. So for the limit x approaching 0 plus, what will we get for the top part? It's greater than 0, right? So, sorry, wait. It's fine. Sorry. Oh, so for the first one, the x between 0 and 1, we can give the x the value of 0. And for the -1 until 0, you can get the x is equal to -1. So for the 0 plus, it's between the 0 and 1, right? It's greater than 0. So it's some small number like 0.00 and 1. So it's greater than 0. Then we can round down it to 0, just 0, over something that's small enough but close to 0. So the answer is 0. Yeah. And for the limit that approaching 0 minus, it's 0 minus, we get this one. So minus 0.0001 becomes -1, right? And the bottom part is 0.1 minus. So this one cancel out and give you the 1 answer as the answer. So by comparing the left hand side and the right hand side limit, we can conclude that the limit x approaching 0 is same, do not exist here. Any question here? Okay, can continue to the next question. Limit approaching 2, 4, 3, so first we try to substitute it first, and we get 4 minus 4 over minus 8 is equal to 0 per 0. For this problem, we can try to factor this one. So, limit approaching to sorry. The t square minus 4 is easy, right? T minus 4 and t plus 4. So what about this one? What's the factor of 3 or of 3 cubic? That's the answer. Okay, we're going. It's 3 minus 4 times t squared plus this one is 2 squared, 2 t. Sorry, wrong one. It's 2, right? It's supposed to be 2. Sorry, 2 plus 4. This is the factor, so it is we can multiply this 1, 4, 40, minus 40 and minus 4. You get this one. So 3 minus the 3 is same as a min b times a squared plus ab plus b squared. Okay. So from this one, you can cancel this out. Something from the limit, if you cancel something from the denominator, it's 80% you are done. And then you can substitute the 2 back to the limit. Sorry, not this one. This one. Substitute the 2 to the limit, and you can get the 3 is approaching 2 is 2 plus 2 over 2 plus 4. Sorry, 4 plus 4 plus 4. This one. 2 plus 2 is equal to 4 over 12, which is 1/3. Okay. Is it clear? Okay. And for next question, the limit x is approaching 0 for cos b plus sin x. Yes. So how can we solve this? It's actually pretty easy. You can just substitute the x and get the answer already. So you can get the x. 0 cos b plus sin 0 is 0. So you can just calculate the answer is cos b. What's cos b? Anyone else? I forgot to bring the calculator. I think it's -1, right? -1? Yeah. Okay. Okay, this is pretty easy one. Next one. This one. Limit t approaching 0 for p cubic or tan cubic 2t. So to solve this problem, we have to know the limit, some basic limits, like the sin x over x as limit x approaching 0. This is equal to 1, right? Like the proof that Prof. Iman provide. And actually, there are some others like this. Is same as this, x approaching 0. It's tan x over x. This is equal to 1, 2. Limit x approaching 0, x per tan x is same. It's equal to 1. So how can we get this from this problem? We can write it again. 0. We have the 2 here that we cannot do. So we can just divide it into 3 parts. So the limit 3 over 0 t per tan 50 t per tan 50 times 3 per, and we can multiply it each one by 2 over 2. It's basically 1, right? Everything. So from this one, we know that this is 1, right? Hey, yeah, that this is 1. This is 1, 2, and this is 1. So basically, the limit is just 1/2 times 1/2 times 1/2. 1 over 8. Just like this. Okay, is it clear? For our next problem here, we have just like the Tuesday, the last Tuesday, Professor Iman said this. The problem like this. It's our last question for this class. So anyone want to try this one? Hello. No one. Okay. Just discuss this now because there's not much time left. So as the limit approaching 0, first to solve this limit, usually we use the conjugate, right? So we just times it with x plus b plus 2 over b plus 2. So this is become x plus b minus 4 over x, that's x plus b plus x plus 2. That is, we want the answer to be 1. So one thing that have to be cancelled out is the x1 right here, right? So the denominator doesn't get to be 0. So it has to be cancelled out with something on the nominator here. So the first thing that has to be done is to cancel the b1 here, to eliminate the b. So we know that the b is equal to 4. So it's cancelled out with the 4. So we can conclude that the b is 4. And so the limit becomes x approaching 0, ax over x, ax plus 4 plus 2. Yeah. And the x cancel out. So we get this. It is a over x plus 4 plus 2, it has to be equal to 1 if we put the zeros in. So this becomes zeros. So a over square root of 4 plus 2 equal to 1. So sorry, here a over 4 equal to 1. So the answer is a equal to 4. Why what? But we cannot cancel out if we have something that's on the top, some constant on the top here. So we need to cancel the 4 here. And how we cancel that one is by giving the B4 here. Oh no, it's like you have to cancel out the x, and you have to make the nominator here as a 1x here. So it cannot have something like plus something plus constant. So you can just cancel the x from the bottom here, because we want the result to be 1, right? If there is a x on the bottom here, then if you input the x here, it will be 0, all the denominator here. Yeah, is that clear? It's like what? Okay. Okay, is there any question for today's class? It's actually set for 1 hour, right? So that's all for today. And thank you. Okay, sorry for that. Oh, sorry, please get my English. Okay. Which one? Oh, sorry. Which one?
Second.
This one. Okay. Ah, so the sign here is means that you have to round down the integer to the closest digit. You understand it? So if it's 2.999, it's become 2, something like that. So for the limit approaching 0, you have to check at the left hand side and the right hand side limit if it's same or not. Okay. And for the limit approaching 0 minus, which is this one, 0 minus is less than 0, right? 0 minus. So it's something like minus 0.0000001. and that's rounded into -1. Okay, and if it's 0 positive, 0 plus, it's rounded to 0.
Yeah.
So if you input that into the 0 positive, it becomes 0 over something that's really small, but not the 0, right? The 0 positive. So the answer is 0. Okay, you get it? And for the -1, you get the -1 over something that's, oh wait a minute. Oh wait, this one is supposed to be infinity, sorry. So it's a number over something very small, close to 0, right? Sorry, this one is supposed to be infinity. And so the limit from the right hand side and the left hand side is not equal. So the limit from x approaching 0 do not exist here.
I see.
Okay.
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 So we go ahead and take a picture of
Okay.
the
We
question
can take.
page.
Oh, question.
Thank you, sir.
Okay. Okay. Okay, for the online student, do you have any question? Okay, thank you. And that's all for today's. Thank you. Oh, anyone? No one. Okay, I'll just leave it here for a second. Okay, what?
The same question.
Oh, okay. Oh, yeah, that's basically. Yeah.
Can you tell me more, because I still
Okay.
don't know.
So let's see the problem here.